Okay, in this video we're going to look at a specific example, and what it is we're going to look at this function down here. We're going to discuss or describe its continuity. And what I've gone ahead and done is I've left these definitions up from the previous lesson, and you can read these on your own. I'm not going to read them to you, but this is how we describe continuity on an open interval. Open interval is right here, and continuity on a closed interval right here. Okay, so let's go ahead and discuss the continuity of this function then. To do that, I'm just going to use my layman's definition of continuity to help me describe where this thing is discontinuous. Okay, so as I trace this function out with my pen or pencil, I'm just noting all the places that I have to pick my pencil up. I have to pick my pencil up at -3, and I come back up here, and then I have to pick it up again at 2 until I get to here at 5. I pick my pencil up at 5 and jump down here and finish my function. Okay, so really I had to pick my pencil up 3 times. I picked my pencil up at -3, +2, and +5. Okay, it looks like we're continuous everywhere else on this function. Alright, now let's go ahead and talk about where this function is continuous. Okay, we know where it's not continuous, so we can say that f is continuous on an interval. What interval? Well, this first interval that we're going to look at is from -infinity until I have to first pick up my pencil, and that occurs at -3. So from -infinity to 3. Okay, so my question to you then is, does that include 3? Does the continuity on this interval right here, does it include the endpoint 3? And you may have to go back to this, what it means to be continuous at the endpoint of an interval. But you can see here that if the limit as x approaches b from the left, okay, b's right here, if that equals f of b, then we can go ahead and close this bracket off. We know that the endpoint will be included in our discussion of continuity. The only problem there is that -3 doesn't exist as far as our domain is concerned. Okay, -3 is not in the domain. Therefore, the limit of f as x approaches -3 from the left-hand side cannot possibly equal f of -3. This should be a negative right here. Okay, unioned. This is just a U for union. Union with what? Well, we jump to the other side of -3, and then we continue until we hit our next place where we pick our pencil up, and that happens to be right here at 2. Okay, so again, I ask you this question. Do I get a closed bracket, a bracket here, that includes 2, or a parenthesis that doesn't include 2? And remember, to be able to talk about continuity at endpoints of an interval, then the limit of the function as you approach that number should equal f of that number. So ask yourself, does the limit as x approaches 2 from the left of f, does that equal, I'm going to put a little question mark here, does that equal f of 2? Okay, and the answer is no, it doesn't. 2 gets mapped up here, wherever that is. It certainly isn't down here. Okay, so we are not continuous at this point. Therefore, we do not get a bracket, but rather a parenthesis. Okay, unioned. Unioned with what? Well, we jump to the other side of 2 now. I ran out of room. We jump to the other side of 2, and we just keep going until we run into our next discontinuity, which happens to be at 5. Okay, so once again the question, open parenthesis or closed bracket, what is it? Well, as we approach 5 from the left-hand side, from the negative direction, what is that limit? And it looks like that limit is f of 5. Okay, so that fits this description right here. So we can go ahead and include that endpoint. Now, I need to point this out to say that this does not mean you're continuous at 5, okay, because clearly we have a discontinuity at 5. We're just saying that we can say that we're continuous from 2 to 5, including 5, because it meets this requirement defined right here. Okay, now, one last interval to talk about, unioned. We jump to the other side. Okay, same question. Can I include 5 in my discussion of continuity on the interval 5 to infinity? Okay, can I include 5 in this description? I included it here, but can I include it here? Well, if we look back at the graph and we approach 5 from the right-hand side, okay, what is the limit of f as we approach 5 from the right-hand side? And the answer is the limit is going to be this value right here. I don't know what that value is. Let's make one up though. Let's say that it's 1. Okay, so the limit of this function as x goes to 5 from the right is 1. Well, what's f of 5? Is it 1? No, it's up here, maybe at 3. Okay, so here's a case where the limit as x goes to 5 from the right of f does not equal f of 5. Okay, we saw f of 5 equaled 3, and the limit equals 1. Okay, so we do not get a bracket, but rather we get a parenthesis. And we're done talking about the continuity of this function. I guess one last thing to do to kind of wrap all this up and to be thorough is to talk about what kinds of discontinuities these are. This asymptote would be a non-removable discontinuity, as well as this jump right here. This would also be a non-removable discontinuity. And then at 2 here, this would actually be a removable discontinuity. If you forgot what those were, you can go back a couple of videos and watch what it meant to be non-removable versus removable. There you go. I hope that made sense. Thanks for watching.